First up, or for today, we have 2.8. We're talking bisectors. All right, so first thing we have is recall that M is the midpoint of AB if we have A dash M dash B. We talked about this yesterday some, remember? I think. Okay, hopefully. All right, and AM equals MB, or the segment AM is congruent to segment MB. Our warm-up today, all of that just kind of goes together so nicely. Okay, because I did do it on purpose. Actually, the book kind of did it on purpose, and I just used it. So if A and B have coordinates AB, respectively, then we would say this, we could find the measure, right? So AB equals the absolute value of A minus B. So we could find that length there. Okay, so we're going to dive right in. For example 1, it says find the coordinate of T if the coordinate of M, the midpoint, of RT is 2, and the coordinate of R is 5. Back the train up. What? So what was one of the helpful things that we could do yesterday that I told you it's really good to do? Breathing is good. Graphing, yeah, draw a picture or graph. You know, like in this case, we can kind of draw a number line and therefore graph it. So from the information we have, it says find the coordinate of T if the coordinate of M, the midpoint. Okay, so we know M is the midpoint. It's 2, right? We good with that? And it says find the coordinate of T if the coordinate of M, the midpoint of RT, so we know our endpoints are R and T, and the coordinate of R is 5. Well, so is R going to be to the left over here, or is R going to be to the right? Yep, to the right. Okay, so here's R, and that's 5. So, can you figure out T? So we know T goes... Yeah, we know T is -1 just from our picture, but we're going to actually use a formula to help us. But how did you figure that out? Right, so here, that's a good call. All right, here we added 3. So if we're going back this way, we're going to subtract 3. How do you know that it's 3 both directions? Because M is the midpoint. The midpoint means it's in the middle. Right, so all these things that you know, like...
I never understand why we would have to put things into equations if you can just look at it and figure it out.
I know, it's true. So, because here's the thing. We give you an easy one to start with, and then we make them, they become a little bit more difficult. So here's the thing. If we know MR equals MT, do we know that? MR is equal to MT? Perfect. Okay, then MR, we just want to practice using this. Okay, MR is equal to what?
Would it be
3?
Okay, but we want to practice using this formula, the absolute value of A minus B. So M is 2 minus 5 equals the absolute value of -3. So MR equals 3. Okay, because we're practicing. All right, so MT equals the absolute value of 2 minus, no, MT minus -1. So the absolute value of 3 is 3. Okay, so any questions there? No. Okay, so we're just practicing using that notation to find out how long our segment is, if we need to do that. All right, so then let's get to our midpoint theorem. That was kind of crazy. Could have been.
anyone in here?
Yeah, right? I was like, the board is falling down. The board is falling down. No. Okay, so if M is the midpoint of AB, then AM equals 1/2 AB. That make sense? Right? M is the midpoint, so it's the same thing here. M is the midpoint of TR. Then if we said MR is half of TR. We good with that? Okay, it's half of the whole. All right, so the coordinate of the midpoint M, there's a formula here we can use. M equals A plus B, so the two endpoints, divided by 2. So in this case, if we used it for T and R, we would say the midpoint equals our T is, or let's see, so no, it's 5, or yeah. So -1, you're right. So yeah, I started to say 5. So -1 plus 5, if we're using the example we just did, divided by 2. -1 plus 5 is? Right, but -1 plus 5 is 4, divided by 2, and so that equals 2. Well, wasn't that where our point was for M? Was that 2? Okay, so we can find our point for the midpoint if we use that formula. Or it says, you know, the coordinate of the midpoint. That's the formula to find the coordinate of your midpoint. And we're going to do that in example 2. We're going to find the coordinate of midpoint M. Got it? Okay. All right, so in example 2 then, find the coordinate of midpoint 2, or midpoint M of PQ, segment PQ, if P equals -15 and Q equals 7. Then use the midpoint theorem to verify the result.
Midpoint theorem, the equation, or is that the diagram?
The midpoint theorem is, well, the 1/2, like AM equals 1/2 AB. So we're going to prove it. So to do it, we're going to use that M, the coordinate of the midpoint, equals, what was it?
Doesn't equal.
Well, it doesn't equal A
Oh,
in
yeah,
this
okay,
case.
so it'd be,
Let me change it because we're not using the variables A and B anymore.
P plus Q
Okay,
divided by 2.
P plus Q divided by 2. Are we following? Okay, so this is going to be -15
Plus 7
plus 7.
divided by 2, so -8 divided by 2 equals 4.
So M, the midpoint, is at -4. Perfect. Now, okay, questions? All right, so now it says use that midpoint theorem to verify the result. So the midpoint theorem is the one, oh, it's like something changed. The midpoint theorem is the one that said, so we've got PM and Q. Yeah, so PM equals 1/2 of PQ.
Oh, and so PM would be -15 plus -4 divided by.
Okay, so -15 plus, what'd you say? -4?
4 equals -2. Yeah.
What's,
Absolute value signs.
mm-hmm. Yeah, because we just talked about before, like AB from the very top of the recall, right? We had AB, so that length equals the absolute value of A minus B.
Oh yeah. So it would be
So
-15 plus 7.
with that being said, did we do PM correctly? Are we lost? Okay, I got a couple that are some shoulder shrugs. Okay, so we recalled this at the very beginning, but our midpoint theorem said, this midpoint theorem said AB, or pardon me, AM, AM, because A to the midpoint equals half of AB, the whole segment. Okay, so we're using that and applying it to the coordinates that we have. One thing we didn't do that might be helpful is to what? Draw a picture. Like if we could draw a picture. Sometimes that helps just to be able to see it. So our midpoint is at -4. Let's see, P is at -15. And Q is at 7. So we're saying PM, okay, is equal to half of P to Q. And we're trying to prove that. But in order to do that, we have to find the distance of PM. So that's the absolute value of A, or P in this case. So the absolute value of P is -15 minus the absolute value of M, or minus our M value, which is -4. Are we tracking? Thumbs up. Okay. Equals 1/2 our distance of PQ. So what am I going to put in there, Tori? -15 minus -7. Good. Okay. So then we're ready to solve it. So -15 minus a negative is the same thing as plus a positive. What's -15 plus 4? -11 equals 1/2. What's -15 minus 7? -22. So the absolute value of -11 is 11 equals 1/2. What's the absolute value of 22? -22? 22. So we have 11 equals what's half of 22? 11. Check. It works out. We just proved that it worked. So we just proved that it is a midpoint and that everything checked out. Okay. Okay. So then the segment bisector. All right, bisector is another word just like, or it's kind of a word kind of like midpoint, right? It intersects a segment only at its midpoint, but it bisects or intersects. So any line, ray, segment, or plane forming right angles where it intersects at a midpoint is a perpendicular bisector. So that's a special type. Okay, so all it's saying is if I have a line like this, right, I've bisected my line at its midpoint. So this side has to be equal to that side because where this happened. That makes sense? Okay, or you can have perpendicular bisectors. So that one's perpendicular and it bisected it equally. Okay, so it's still a segment bisector, but it just happens to be perpendicular. So we're going to do a construction. Do you have your compass today? All right, so you need to grab your compass. I'll pause our video and you can go get your compass. Okay, so now that we're all back, we want to do construction 4 is a perpendicular bisector. So if we're given segment AB, which is right here, we want to construct a perpendicular bisector of AB. All right, so we're going to use a compass to verify AM equals MB and a protractor to verify that we have right angles. It'll be okay. We'll trust you on this first one. All right, so to do this, we're going to use our fixed compass. All right, so measure it up against your length, A to B. Let me change this around. It's kind of hard to do on the, oh, it's gone the wrong way. All right, so measure out AB. You already measured it. Okay. Then, I am going to turn my thing here. I'm going to put my B on this point. A screwdriver. I do not have a screwdriver to tighten it. I do have one you could borrow. Yeah, I'll bring a screwdriver to class because they do keep slipping. Okay, so now that we have that, okay, we're going to take this and we're going to make an arc at the top and go down and make an arc at the bottom. And you're like, what? This seems so crazy, Miss Talbert. I know. Okay, so do you see that? Like we're just making the little arcs at the top and the bottom.
Oh, the little arcs? I just made a huge arc.
It's okay if you made a huge arc. It's cool. Because then we're going to move our point to the other coordinate, so to A. And we're going to make our arcs intersect. Ta-da! So you see where they intersect? And that gives us the points to connect to have a perpendicular bisector. All right, so I just opened my compass out of its package. And, oh, there it is. Okay, so then I'm going to use my compass, or my protractor here, to connect these.
Oh yeah, that's definitely straight.
Right, and so there is my bisector, perpendicular bisector. And if I measured it,
Close enough.
it's a 90 degree, like I mean, it's a perfect 90 degrees. Isn't that cool?
Yeah.
Like,
It looks kind of like a fish, though. Mine does.
yeah, it does kind of look like a, yeah. And so it says use a compass to, so this point right here, what is this point right here? The midpoint, M. All right, so and it says to use your compass to verify that AM equals MB. So check that measurement. Whoops. Okay. So
Off, but you know.
it is your first time. Okay, so mine's right there, and then if I flip it over to the other side, it's right there. So they are congruent. All right, or equal. The measures are equal. It's just like kind of a cool way to measure things without actually measuring things with a ruler. Like we always think about how we measure stuff, right? Like using circles to make straight lines. Say what? Kind of crazy. All right, let's flip it over. Um, let's see. Yeah. Okay, so the congruent segment bisector is here. I don't know. All right, in page 98, it says right there is the proof. I did not copy the proof down. If you want to look at it, it might be helpful for some of you. It's there on page 98, but that's why. So the congruent segment bisector. If two congruent segments are bisected, then the four resulting segments are congruent. Okay, so if we have these two lines and we bisect them, well, this is the segments, right? If both are bisected, because bisection means it's the midpoint, right? Then K or XA is congruent to AY, which is congruent to KB, is congruent to BL. Okay, so that's that theorem that they're all congruent. Bisectors divide objects into two equal parts. Okay, so we have angle bisectors as well, and not just segment bisectors. So if we look at this one, ray YT, so right here, ray YT, is the angle bisector of angle XYZ. If ray YT is the interior, what's interior mean? The inside. So if angle YT is inside of angle XYZ, and if the measure of angle XYT is equal to the measure of angle TYZ. Kind of a mouthful. Are there questions about that though? Okay, so that's what it's saying, like their notation here is, right? Angle 1 has to be congruent to angle 2 for this segment to be a bisector. an angle bisector, or this ray, sorry, to be an angle bisector. So that takes us to our angle bisector theorem. If YT bisects angle XYZ, then, so here's the theorem, the measure of angle XYT equals half. So this measure is half of the whole measure of angle XYZ, right? Because we're cutting it in half. So construction 5, bisect an angle. Okay. So we're going to place the point of your compass on the vertex and of our angle.
I have an angle.
You don't have the angle there? Did I take it out of your notes?
Sorry, wrong one.
Okay, I was like, did I take it out of your
Wrong
notes?
side.
Okay, so you want to draw an arc. It doesn't matter where, just across both of those lines. Okay, make sure it intersects both of those lines. So we have our arc. All right, and we're going to label those B and C, so we can talk about them some more. Okay, now we're going to place the point of the compass on B, a point of intersection, and we're going to draw an arc up here, just like we did up out of the way for our perpendicular bisector. And then we're going to do the same thing with C. Put your point on C and go up there and intersect those arcs.
What was the measurement?
Whatever measurement you made here, it stays all the same. Yep, it stays all the same. We're just moving the point to where it is. And then you can draw your line from that point of intersection to A. And now you have an angle bisector. Wow! That's about perfect? I'm like, we could, let's see. It's hard. I got this other thing. It's a little easier to measure, but let's see. My whole angle is about 40. Oh, it'd help if it wasn't flipped over backwards. Yeah, I'm not quite 40. And then, or it starts out at 40 over here, and then it goes to 20. So my line, when I drew the original lines, I didn't use a straight edge, so it throws me off a little bit. Okay, but very good. So the last theorem we're going to look at today, or talk about, is that congruent angle bisector theorem. If two congruent angles are bisected, then the four resulting angles are congruent. It's the same as that congruent segment bisector at the top theorem, but now we're just talking about angles. So if we have two angles and they're both bisected, then now we have four equal angles instead of, we'll still have two congruent angles, but now we have four. Does that make sense? Lucas, does that make sense? Okay. All right, so try that on your own there, and then you can get started on homework.